Hello there, Mr. Sutton here with the IM3 Honors 1-3 Extra Practice Number 1 solutions on piecewise functions.
On this oddball problem, we're being asked for the range of the function given in this graph here. So basically, I need to figure out the lowest and highest y values that this graph goes between. So at our minimum y value, down here at the bottom, we have a y value of -3 right here, and it's a solid dot. And then for the max y value going up, we can't get any higher than 4. Now, just double checking here, we don't have any gaps in coverage in between -3 and 4. We have a solid dot, or open dot here, but there's a solid dot to kind of take the place of that. We do have some open dots up here at y equals 1, but there's this solid piece of the line taking that spot. So we've actually got all the y values covered in between -3 and 4. Since the function also is defined at -3 and 4 because we have solid dots there, I'm going to use brackets on both of those. So I'm going to say bracket -3, 4 bracket, and that's giving me answer choice C. For this piecewise function to graph it, we'll start with the first rule, which goes from -infinity to -3, and then we'll graph the second rule after that. Now this first rule is just a horizontal line. It always gives me an output of -1. So I want to find the first endpoint for this rule, the place where we're stopping at -3, the x and y value. I know that's going to be a y value of -1 because, again, it's a constant function. So my endpoint then for my first rule is -3, -1. That's the point where this line is heading towards as you move from the left. And since we included -3, we have an equals on the inequality here. That means I do a solid dot at -3, -1. And since this is a horizontal line, slope of 0, that means I just have a horizontal line going up to this point that I just drew here. Next, I'm going to draw the second line, which is 2x here, y equals 2x. Now to figure out where this thing starts, the starting point at -3, I'm going to plug -3 into this second rule, so 2 times -3, and that gives me a y value back of -6. So that's telling me I have the point -3, -6 that this second rule is starting at. That's going to be an open dot because we had no equals on the inequality with -3. So let me see here, -3, -6, all the way down here, open dot. And to get the line here, I need another point. I can use this slope of 2 that I see in that function. So that means starting at my open dot here, I'm going to go up 1, right 2 to get another point. And now I can just draw a line through those 2 points to get the second part of this piecewise function. On this problem, we just have to graph this piecewise function. So we're going to take this one branch at a time. To figure out what we're doing for this first branch, this one is for the cases where we have x less than 5. So I know I'm going to be going forever to the left, but we're going to stop at 5, and we're going to have some kind of endpoint. So to find the endpoint, let me just plug in the x value 5 to this first rule here. So 6/5 times 5 minus 3, and that'll give us the x value, or actually I should say the y value of our first endpoint. So let's see here. 5 divided by 5 is 1, times 6 is 6. 6 minus 3 is 3. So that means that when I plug in 5, I get 3 back. So I have the point 5, 3 as an endpoint for this first rule. Now, since this is a rule for where x is less than 5, since there's no equals there, this point here, 5, 3, we're going to use an open dot just as kind of a placeholder for that, since this rule doesn't actually apply when x equals exactly 5. So we have an open dot at 5, 3 right up here. Now we need something else to graph this. These are both lines, so we always need 2 points to graph a line. And you've got some options for how you get this next point. One way you could do this is just seeing that we have a slope, since these are both in mx plus b form. We have a slope of 6/5. But it's kind of hard to go up 6, right 5. You actually could go down 6 and left 5, and that would give you the same slope if you just reverse both directions. Another way you could do this is you could see that we have a y-intercept of -3, which means we have the point 0, comma, negative 3, which again gives you this spot right here that the slope would have given you. So either way, I'm going to put a dot here just as another place to help me graph my line, and then I'll just draw my line going through here with an arrow as I go to the left. Not as I go to the right, though. We're stopping at that open dot there for that branch. Now for the next branch here, the next rule, we need to figure out the y value where x equals 5 using this other rule. So I'm again going to plug 5, my border value, in for x, but in this second rule now. When I do that, 2/5 of 5 is just 2, plus 1 gives me 3. So I again get the point 5, comma 3. Now things have changed a bit. Since this is a rule where x could equal 5 as well as be greater than 5, that means that we're going to have a solid dot at 5, comma 3. So where this open dot is, it was kind of a waste because we're just going to put a solid dot there anyway, but at least we're doing it for the right reasons now. We do need another point to graph this line, however. So the easiest way to get the next point, I think, is just to use this slope of 2/5. So that means we are going from this dot right here at 5, comma 3, we're going up 2, right 5, and putting another dot, and then just graphing a line through those. And this is our total piecewise function. Now we're trying to graph this piecewise function, which consists of two lines, where one stops and the other starts at x equals 4, so about here. In order to graph this, I know that my first rule is going from somewhere at x equals 4 forever to the left, and then my other rule is going from 4 forever to the right. So I'd like to figure out kind of the point where this first rule stops, and then I can go backwards and graph this first branch from there. So if I plug 4, my border value, in for x in this first rule, that'll tell me the y value that this thing is heading towards. So let me do 3/4 times 4 plus 1. 3/4 of 4 is just 3, plus 1 gives us 4. So this means that this first rule here heads towards the point 4, comma 4. Since this is a rule for where x is less than 4 but not equal, that means at 4, comma 4 I'm going to put an open dot as kind of a placeholder to anchor this thing in space. So 4, comma 4 right here, open dot. And now I need one other dot to help graph this line going backwards. So you could use the slope of 3/4, but you'll have to go backwards. So instead of going up 3 and over 4, you'd have to go down 3 and left 4. That would bring you to this spot right here. You'd also get that spot if you realize that we have a y-intercept of 1 based off this mx plus b form here. So that's the point 0, comma 1. So either way, we put a dot right here, and we're going to just draw a line through those. Now we turn our attention to our second rule. So for this one, I want to figure out the y value and x value where this thing is starting. So I'll plug 4 in for this particular rule, 3/4 of 4. And that's going to give me just 3. So that's the y value 3 to go with an x value of 4, so 4, comma 3. Since we have the equals at 4 here for this rule, that means I have a solid dot at 4, comma 3. So over 4, up 3, solid dot right here. And now I can just use my slope of 3/4 to draw another point. So starting at this dot that I just put right here at 4, comma 3, I'm going up 3 over 4, and I'll just draw a line through those. For this problem, I'm trying to write a piecewise function to describe this graph. Seems like a tough task, but these are all horizontal lines, so all the rules in my piecewise function are just going to be constants, and I'm just going to have to put the constant and what the range of x values is for each of these. So let me set up a big piecewise function. I've got 3 different looking horizontal lines, so let me leave enough room for 3 different rules. Going from left to right, my first rule, my first constant, right here, this looks to be the y value 10, because it looks like these grid lines are going by 2s. So this is 10. Now the x values that's happening between are 0, and it looks like 5 here. But we're including 0, we're not including 5. So I'm going to write 0 less than or equal to x, and then just less than 5. No equals on the 5 because we have an open dot there. For my next rule, let's see, this looks like it's going to be at about 7, and that's happening between the x values 5 and 25, including 5, not including 25. So I'll write 5 less than or equal to x less than 25. And finally, my last rule, I've got, let's see, this looks to be 5 for that y value. And that's happening for all x values that are greater than or equal to 25, so I'm just going to write that. For this problem, I'm trying to create a piecewise function for this graph, which consists of 4 horizontal lines. So that's going to be 4 different rules that I'm going to have to leave space for in my piecewise function. And each of these rules is just going to be a constant, since these are all horizontal lines. So my first constant, going from left to right now, is going to be, let's see here, these grid lines are going by tens. This is like half of a grid line, so that looks like 45 roughly. And that's going from the x values 0 to 3, it looks like, because each of the vertical grid lines are going by 2s. But now I'm including 0, I'm not including 3. So I'll have 0 less than or equal to x less than 3. No equals on the 3 because we have an open dot there. And we'll do the same kind of thing 3 more times. So our next horizontal line is at the y value, looks like 55. And that's between 3, where the last one left off, and 6, not including 6. So we can write 3 less than or equal to x less than 6. Next, this horizontal line, this third one, is at 70 for the y value. And that's between the x values 6 and this looks like 11, not including 11 though. So we can write 6 less than or equal to x less than 11. And finally, this last horizontal line is at 80, and that happens for all of the values that are greater than or equal to 11. We have a solid dot, so we have to include 11 in this one. So we'll do 80 if x is greater than or equal to 11. And that's our piecewise function.